Hello, my friends. We are looking at enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. Now, secret messages is an extremely interesting project where we look at cryptography. In fact, we look at classical cryptography. We see how we can take a message and either jumble it up, which is transposition, or replace every character with some other character, which is substitution, to create a secret message, which then it gets hard to read, and we need an algorithm to sort of understand what the message is saying. In the second part, we look at something called a Caesar cipher. Let's look at a few more substitution ciphers which could act like an enhancement to your project. The first one that we are going to look at here is this thing called the Atbash cipher. Now, this is a very, very simple cipher. The idea is that we are going to replace every letter by another letter in a sort of reversed manner. Now, what do I mean by that? Well, every A is going to get replaced by Z, B by Y, C by X, and so on and so forth, which means every Y will become B, every Z will become A. Now, you can clearly see that this cipher is something that can be applied to any alphabet. Here we are looking at English alphabet. It's not very secure, but it's self-decoding. And what do I mean by this? Well, basically, if A becomes Z, Z becomes A, which means that if I take my message, I encode it with something. If I run the algorithm again, I'm going to get back my original message. Notice also that the shift depends on the letter. So, in Caesar cipher, for example, every letter gets the same shift. Here, that's not true. In fact, the shift that is happening is given by, depends on the letter. Like I said, so 0 becomes 25, 1 becomes 24. If you look at the pattern here, you realize that we are replacing every letter by 25 minus the index of the letter. So what I'm going to do is that I'll take my Caesar cipher code and I'm going to modify this, by just saying that, okay, look, my new index is going to be just 25 minus index. Now I have a string here called letters, which contains for me all the letters. All I'm going to do really is that I'm going to say, look, everything remains the same like a Caesar cipher, but I just change the way the new index is computed. And notice this is completely self-decoding, which means that the same code will work for encoding and decoding. Now, why 25? Because, well, there are 26 letters in the alphabet. So if you're building it over a bigger alphabet, or you want to say include numbers in this or something like that, go ahead and do this. But remember that it will be the length of letters. So if you want to make it general, you can just say length of letters minus 1 minus index, and then you're good to go. Let's see this in our code. Like I said, I'm just going to take my Caesar cipher code. Let's say here. So I just duplicate this and I call it, let's say, Atbash Cipher. I don't need to say give any n here because that is understood. There is no n here. Now, like I said, all I'm going to do is that I'm just going to make it, the new index is given by, say, 25 minus idx. So basically find the index of this, find the index of the present letter in the list letters. That tells you where the present letter is. Just change it to 25 minus that number and you are done. So we can just run this and see what happens. So here, for example, I say Atbash, cipher. Let's say I try A, B, C, D. We get Z, Y, X, W. That's because A becomes Z, B becomes Y, C becomes X, and B becomes W. Now, again, if I were to just reverse this process, so I say Z, X, let's say Z, Y, X, W, I'm going to get back my original message because, as we discussed, this is completely self-decoding. Now, we can run this on a more, let's say, general message. So I go and say, for example, Atbash Cipher, let's say, meet me in the lobby at, say 6 p.m. Now, before I run this, I just want to highlight that I have intentionally used a small case m, because remember my my string letters, which is defined up here, contains only small letters. Also, I've avoided using any numbers because, that will run me into problems. We have previously seen how we can enhance the Caesar cipher for, say, capital letters, for, let's say, numbers, and so on and so forth. You can apply similar arguments here to enhance this as well. But if I were to just run this, I'm going to get, so if I run this, I'm going to get something quite interesting. Now, from the first look, it's really not so obvious. So let's just do, let's just assign this to something. Let's say we call it AA is equal to this. Now, if I run this Atbash cipher once again, Atbash cipher on this AA, then I get my message again. Now remember, this did not look all that obvious, but obviously we know that this from an Atbash cipher. I run it again, I get the message. I hope you found this interesting. In general, if you think this way of learning Python is fun, it makes you think, it makes you enjoy programming, do look at our website because that is how we learn programming at ybyte.in. Take care. Thank you so much. Bye bye.